Well, welcome back, ELE 112. We are now in Chapter 8, Section 5. We are officially into some of the big boy sections, big girl sections. This is Thevenin's Theorem. It's very cool and sometimes challenging to grasp. You'll kind of understand the idea. You might have trouble implementing it, but here goes, okay? Thevenin's Theorem, as all the other stuff in Chapter 8, are higher level methods of solving complicated circuits to an equivalent form. I recommend taking notes. I recommend you read the book. I recommend you consult other videos online. I recommend you talk to people. Whatever you can do will help you with this, okay? But the bottom line is, here's what we're after. It's a technique of circuit analysis, usually often in need of simplifying before doing analysis. This would be great where the same circuit must be solved over and over and over. For example, an audio circuit with some sort of a source driving it there in the example has a complex circuit of, say, 1,000 parts. That's a big circuit. You're going to plug in a speaker. You're going to plug in a resistance. You're going to plug in some sort of impedance to it. And that impedance, when it plugs in, changes the operation of the circuit. So the question becomes, hey, if I desired to analyze this problem 5 times with a 2 ohm impedance, with a 4 ohm impedance, with an 8 ohm impedance, all the way up to 32 ohms as shown in the drawing around the black circle. If you want to analyze this circuit multiple times, that could take you days to get through, just to solve it 5 times. Well, Thevenin developed a technique called Thevenin Circuit reduction. And what it does is it takes those 1,000 parts and reduces them down to one simple component called a Thevenin resistor and a Thevenin voltage. Now, that doesn't just happen by magic. There is some technique involved, and that's what we're going to learn. So, what you're looking at there is your first look at a Thevenin circuit. It is a voltage source of some sort, not the same source as the one in the circuit above this one, highlighted by green dot, okay? Not the same power supply, a transformed different level voltage, and an R Thevenin, a resistance Thevenin, which will have to be computed, and that Thevenin resistance, that Thevenin impedance, works for AC and DC circuits. That's required to boil the 1,000 parts down so that you can have one impedance. An amazing process, but doable. Now, both examples are the same. You're trying to solve for multiple loads that you're plugging in. And it's clear that the Thevenin circuit in the second case is far easier than the first and would go a lot quicker. Now, what are the cost repercussions? Well, to do a Thevenin circuit requires you to analyze the circuit one time completely through, which is time consuming. But compared to this circuit out here, you would have to solve that 5 times. So 1 out of 5 ain't bad, right? So here's the other thing to think about as we move into this. And I'm going to have probably 1 to 3 videos on Thevenizing before we finish this particular chapter of study. It's a pretty involved process to put online. Thevenin's is an analysis tool. It's a paper tool. There's no way one part can work like 1,000 parts, okay? There's absolutely no way. But what I can tell you is this circuit up on top has a current called I load. And this circuit up on top has a voltage called the load. And as long as those two current and voltages are satisfied, that load is receiving its proper voltage and current. In other words, to change the way I describe it, the 2 ohm resistor, the 4 ohm, the 8 ohm, the 16 ohm load, they don't know that there are 1,000 parts feeding it. They only know the voltage and the current that they feel. So, if that's true, then the, let me close my tools here. Then the current that is flowing in the Thevenin circuit and the voltage that is flowing in the Thevenin circuit for the load, excuse the mess, would be the same for the 2 ohm load on the bottom circuit. As long as the voltage and current is the same, does that 2 ohm resistor know that it's different? You know, you walk into a business establishment that has 2 bars. You close your eyes. You walk up to one. You have a gin and tonic. You have a Coke. You have a Pepsi. Whatever it is that you drink. You walk over to the second bar. You have exactly the same drink. You're happy. You're happy getting that drink, and you don't care where it came from. So these 2 circuits that you're looking at, whether it's the complicated circuit or the Thevenin circuit, they work identical according to the load that is receiving the current and receiving the voltage. Now, what you can say is that this circuit down here, the Thevenin circuit, once it's solved the hard way one time, the other 4 solutions are a cakewalk. And that's why we learned about Thevenins theorem. Now, before we move into the actual use of it, there's an isolated picture of what a Thevenin circuit looks like. It's a resistor, an R Thevenin resistor, and a V Thevenin voltage source that sits out there, and an open load on the output. That's where we will be installing our loads in future modules about Thevenin's theorem.